In this lesson, we're going to be looking at how to graph a logarithmic function. And it's based on an exponential function because those two functions are inverses. So if you've already seen the video on how to graph an exponential, you may skip to the part where I do the logarithm, but I'm going to quickly review it because you really can't begin that conversation unless you know how they're related. So just a quick review, the most basic exponential function you can have is 2 to the x. You could have 3 or 4 or e, or 10 to the x. And the key points that are made from that are centered around the origin. So if the origin is in the center, to the left, you'd have -1. To the right, you'd have 1 on this axis right there. So 0, -1, and 1. And then if you put -1 into this exponent, you'd have 2 to the -1, which would reciprocate and make that the denominator of a half. 0, anything raised to the 0 power is 1, and 1 would mean 2 to the first power or itself. And when you graph these, you get a nice little graph that I usually tell my students kind of looks like a slide. It looks like that, and that graph is flat on this side, and then very quickly, it's actually called exponentially, rises on the right side. That can be reflected and all those things by different things, which will come later in the lesson. Now, this graph has an asymptote right here on the x-axis. That is a horizontal asymptote, and you might remember the mnemonic device called Hoybucks, which we use to try to figure out kind of frustratingly similar ideas. So if it's horizontal, the slope would be 0, and the equation would be y. So the horizontal asymptote is y equals 0. The y-intercept is right here. It's one of the key points. It's 0, 1. Because there is an asymptote on the x-axis, there would not be a x-intercept. The domain is -infinity to infinity. That's right here. It goes from -infinity to infinity without stopping. The range is 0 to infinity because remember, there is no graph down here, nothing, but it starts at 0 and then rises to infinity. So that's a little review of that. And that makes the end behavior, because the end behavior is the domain -infinity to infinity. That is just this domain put on it in a column rather than a row. And at -infinity, the graph is going to the asymptote or 0. So you would say y or f of x goes to 0. And then on the right side, it's going to infinity. So you would say it's going to infinity. So the end behavior is a combination of the domain and range. So now let's talk about what an inverse is. In general, the word inverse means I'm going to take the entire domain and replace it with the entire range and vice versa in coordinated pairs. So to explain that to you, that literally means that the logarithm is simply going to take these points and inverse them like this. And you can see that right here in the center of the chart. So this coordinated pair -1 to 1/2 would reverse or inverse. This one will reverse to 1, 0, and this one will reverse to 2, 1. All right. Now, if we could extend this, right, this one would be the same thing as an exponential to -2, which would be a fourth. And this would be the same thing of an exponential base 2 raised to the second power, which would be 4. And you might remember my dialogue about logarithms. Logarithms are an exponent. The answer is an exponent, and that's why this is so connected. We are, again, only going to focus on this portion for key points. So why don't we skip to that? The key points that we're focusing on are simply taking these key points and reversing them. So some students have to write down on their assessments the key points for the original and then reverse them. Some students don't. It just depends on your ability to adjust to this reversal. Now, this reversal isn't only in the key points. Let's take a look at the graph, and it'll show you some other things that are happening. So we graph at 1/2, we would graph 1. At 1, we would graph 0. And then at 2, we would graph, my apologies. At 1, we would graph -1. There we go. At 1, we would graph 0. And at 2, we would graph 1. So that makes our graph, and the graph looks like this. It is, again, it is a graph of this, but inverse. And if you remember anything from Algebra 2, an inverse is simply a reflection over the line y equals x. So if I put the y equals x in there, you can kind of see that perfect reflection. Now, again, I've mentioned it several times that an inverse is a graph that is in which all of the domain has been replaced with all of the domain in coordinated pairs. But it also does things like, hey, if I had a horizontal asymptote earlier, right? Now what I'm going to have is I'm going to have a vertical asymptote. So earlier we had horizontal, now we have vertical. Just makes sense because the inverse of y is x, and this is now x. So that's the first thing we're noticing is that there's a vertical asymptote. It's not y now, it's now x. It's still 0, okay? But it's not y equals 0, it's x equals 0. And you notice that the x-intercept is now what is happening. So the y-intercept is gone now. Why is it gone? Because we have moved the asymptote from the horizontal axis to the vertical axis, and so it's not going to be crossing this. Now that point right there is the x-intercept. It is the y-intercept, but inversed. The domain is interesting because the domain will even inverse. So the domain of this one is negative infinity to infinity, which is now the range. And the range of this one is 0 to infinity, making it the domain. Now, if that's confusing, just go back to your analysis. This is negative infinity. This is infinity. Where does the graph start? Going this way, it starts at 0 and then goes to infinity. Where the range starts at negative infinity and goes to infinity. So pretty interesting how that works. And even the end behavior will also inverse and be exactly the same as its inverse, but in the reverse order, because we have to start with the domain. I think I didn't quite finish this. One second. Oh, that's x-intercept. I was looking at the wrong thing. So the domain is 0. So it goes from x to 0. Right, there we go. That's our first part of our end behavior. And then x also goes to infinity. You can see that is the domain. The end behavior always just starts with the domain. And then f of x, okay, is going to go to where the range is. So our choices are negative infinity and infinity. Remember, this is the first part of the behavior. This is the second part, but they don't always match up. It's this is the first part, and then pick the appropriate one here. So as x goes to 0, meaning as x goes that way, the graph is going to negative infinity. And as x goes to infinity or goes this way, the graph is going up or infinity. All right, so the hardest part of this whole thing, honestly, is simply getting the correct key points. So let's just start with that. The key points of any logarithm are 1 over b for the negative one, 1 for 0, and b for 1. They're the exact key points for exponentials, but in reverse. So if I looked at this one that has a base of 3, this would be a third, and then 1, and then 3. Now, if I have a fraction, remember, 1 over b does not mean make a fraction. It means reciprocate. So this would become 2. This would always be 1, and this one is the base. So this would be a half. And just to reiterate that, this one right here would also be reciprocated. This would be 1, and this would be a third. All right, in the next video, we're going to take a look at transformations using this concept.